Today's lesson is section 1, 2, and we're just going to start off by factoring polynomials today. All right, so when we're factoring a polynomial, it means to express it as a product of other polynomials. So think of like your two binomials multiplied together. And if something can't be factored, we say that it's prime. Okay, so we're going to start off pretty easy and then eventually get to a little bit more difficult things. So the first one, example A, just says factor each of these. So when we only have two terms, or no matter how many terms we have, the first thing we should look at is, can I factor a GCF out of all of my terms? So since there's only two, that's my only option. So if I look at both terms, they both have a 2 in common, or they can each be divisible by 2. And then the other thing they have in common is an x. So remember, factoring is like the opposite of distributive property. So then I take 2 divided by 2 and I get 1. X squared divided by x is just x. Minus 4 divided by 2 is 2. X divided by x is 1. So that is the most simplified factored form of the first one. All right, let's take a look at B. Again, we have 3 terms. So we could say, oh, I could factor this like a trinomial, but it has an exponent of 4, so x to the 4th. So let's see if there's something I can factor out of all 3 terms. So if I look at 12, 4, and 6, they're all divisible by 4. And then x to the 4th, x cubed, x squared. I can take an x squared out of all of them. So then doing all of our division, we will get 3x squared minus x plus 4. Okay? And then if I look in the middle, I can see, hey, maybe we can factor this by factoring trinomials. I'm not going to tell you which way to factor a trinomial. All of you have factored before. We're getting into factoring trinomials more in the next lesson. So we're going to leave it like that today. But just so you know, factoring trinomials, in case there's some today that need factored, you may have learned slip, slide, divide, Xbox, the California method, or just trial and error. Any of those would be sufficient. Okay, so here's our answer for B. All right, moving on to C. This one looks a little bit different. Okay, here is one term, and and here is one term. So we look at those two terms and we say, okay, do those two terms have anything in common? And they do. They have my whole expression x minus 3. So we write that down because we're factoring that out. This is like the last step to a factoring by grouping problem. We say, okay, we wrote that down. Now what do I have left? And I have an x squared plus 4 left. Fight the urge to factor this. It's not difference of squares, so we can't factor that. So this would be our completely factored answer. All right, so you can pause the video, try the 2 your turns. I'm just going to write down the answers for them. This one, be careful. That is not a completely factored form because this is difference of squares. So that can be factored into x plus 6 times x minus 6. I'm hoping you all remember that from Algebra 2 and what we've been working on the past few days. So that is the most simplified version. All right, moving on to our last example, example 2. We have to look at this first. So I just said to you difference of squares, but here it is written out if you need it. Okay, we have that difference of squares. It says if we have u squared minus v squared, then it is u plus v times u minus v. We also have our perfect square trinomials, which we went over yesterday and looked at those a little bit. We're just going the opposite way now. These, I'll be honest, I always forget to look for perfect square trinomials. I usually don't recognize it till after I'm done factoring a normal way. So just keep that in mind. It will save you some time if you notice it. And finally, the sum or difference of cubes. This is the one everyone forgets. It's different than what we did yesterday. Yesterday, it was either u plus or minus v quantity cubed. This is different. It is u cubed plus v cubed, and it factors, to save us a lot of time, it factors into this. The good news is addition and subtraction both have the same things. It's just where the addition and subtraction symbols are. If it's addition, we have addition first. If it's subtraction, I have subtraction first. After that, for addition, we alternate plus, minus, plus. For subtraction, we get our negative out of the way, and then everything else is addition. Okay? This trinomial that we have here and here is unfactorable. Okay? It will not be able to be factored, so keep that in mind. All right, so let's see how we use these. So for the first one, if there's just two terms, I look and see, okay, can I take the square root? And I'm looking at square root because that x is squared. If that x was cubed, I'd be thinking about cubed roots. Okay? So I'm looking and saying, okay, can I take the square root of 16 evenly? Can I take the square root of 9 evenly? And the answers to those questions are yes. And since I can, that means this must be, and is there subtraction? I have difference of squares. So the square root of 16 is 4, square root of x squared is x, square root of 9 is 3. So I have a 4x plus 3, and then I do the same thing, but minus 3. And then don't forget to look, can I factor those anymore? The answer is no, so we're done with this one. Okay, let's take a look at B. Oh, I see something to the fourth. I don't have any little things up here to the fourth, so I'm just treating it like a squared. I do have subtraction. I can take the square root of 81. I can take the square root of 1. I can also take the square root of x to the fourth. So this is, again, difference of squares. So difference of square. So square root of 81 is 9. Square root of x to the fourth is x squared, minus square root of 1 is 1. And then I do the same thing, 9x squared, but I do plus 1. Now, don't forget, this is where a lot of people make mistakes. I have a subtraction there, so I'm going to look. Can I take the square root of both of those evenly? And the answer is yes. So this one becomes 3x minus 1 times 3x plus 1 times 9x squared plus 1. Okay, and we're done with this one, part B. All right, let's move on to, I forgot C. All right, moving on to C. So this is one of those that typically I would just factor like normal, but we have our special perfect square trinomials. So if I look at this, that would really, it's a subtraction. So that would be u minus v quantity squared. And that simplifies to u squared minus 2uv plus v squared, or vice versa. So if I look at this, what number was squared here to give me a 4x squared? Well, that must have been a 2x. And what value must have been squared here? Well, that would have been a 3, because 3 squared is 9. So then all I have to do is substitute those values in here. My u is 2x. Since there's a subtraction here, we have subtraction down here, and that is 3, quantity squared. Okay. Hopefully that makes sense to you. If not, factor the trinomial with slip, slide, divide, difference, or not difference of squares, slip, slide, divide, Xbox, California, whichever method you want to. All right, 2 more. I see a cubed, so right away I'm thinking difference of cubes, except this is sum. So that is u cubed plus v cubed, and you can look at these if you need to, but try to learn them. U plus v times u squared minus uv plus v squared. So my u value is y, my v value. So what value was cubed to give me 27? And that is 3. So then just substitute them in here. So I get y plus 3 times u squared minus 3u plus v squared, which is 3 squared, so that is 9. Okay, just using those formulas like we did the day before. And last but not least is E. Again, I see something cubed, so I'm going to say, okay, what is the cubed root of this? Well, the cubed root of that is 2x. What is the cubed root of this? And that is 5. Cubed root of 125 is 5. So then I have u minus v in this case, so I took care of my subtraction, so everything else is addition. Again, in this trinomial that we're writing here, my exponents of u are decreasing, my exponents of v are increasing. So then we get 2x minus 5, whoops, I misread u, times, ooh, be careful here, 2x squared, so I get a 4x squared plus 2x times 5 plus v squared, which is 25. So then we'll simplify this to multiply my 2 and my 5 together, and we're finished. Okay, so you guys have 5 to try on your own. So I will write those answers down for you to check. I am at school trying to beat a bell ringing, so that's why I'm just doing the answers for you. You might have to pause the video a little bit. So I have like seconds. So there's all the answers. We'll just go with that same practice work. And that is all of section P4, day 1.